Welcome to the No-Till Farmer podcast, brought to you by Yetter Farm Equipment. I'm Michaela Pochner, Managing Editor at No-Till Farmer. In today's episode, Brian Young, Weed Science Professor at Purdue University, talks about strategies to fight herbicide-resistant weeds in no-till, including some of the most promising precision technologies to consider adding to your toolbox.
So I'm Brian Young. I'm a professor of weed science at Purdue University. I'm in a typical faculty role where I do research, teaching, and a little bit of outreach, kind of like extension. I'm not officially in extension, but I do a lot of farmer outreach activities. And so my focus has been on weed management, typically in agronomic crops, corn, soybean, small grains to some extent. Looking at herbicide-resistant weeds because that's one of the primary issues that challenges farmers today in those crop systems. So I've been at Purdue University for about 10 years now, and before that I was at Southern Illinois University for 15 years. So about 25 years in the faculty role.
Okay. And I know you're speaking at our National No-Tillage Conference January 9th through 12th in Indianapolis about herbicide-resistant weeds and some strategies for fighting them. So what are some of the key themes for managing resistance in no-till situations specifically?
Well, the one thing is we can't get too focused on any one particular tactic or practice. So, in many cases, we get too focused on the herbicides, and this herbicide controlled it last year, so I'm going to use that herbicide again this year. So, the idea of diversity is not just for, what we hear for cover crop planting, diversity in your cover crops and in your crop rotation overall, but also for herbicides. Rotation of herbicide chemistry that can be effective at managing the important weed species, and then using chemistry with other practices for management of those weeds, such as cultural or maybe mechanical means of weed control. So weeds shift towards anything that's overutilized, anything. Even if we use, for instance, cover crops too much, we'll have weeds that adapt to our cover crop system, such as some of the winter annual grasses will probably adapt to that. And then we'll have those as species that we might not be able to spring terminate. So we have to make sure that we use a diversity of tools. So herbicides, cultural practices, such as cover crops, row spacing is important as well in managing some of these weeds. So I know I didn't get specific there with any one and how effective it is and how much it should be used, because the main message is we need to keep a diversified toolbox to manage these weed species.
Okay. So if I'm a farmer and a no-tiller, and I am thinking about what should I rely on more? What do I need to consider for my specific circumstances when I'm choosing how to manage weeds?
Sure. So when I think of no-till production, I'm going to start with somebody who fits it. They're no-till. They don't necessarily have cover crops because not everybody who's no-till utilizes cover crops. So in that system, obviously herbicides are a key component when you can't use tillage or mechanical means for weed control. So I think part of it is just limiting weed seed production in your fields. So during harvest of the year, if you have a few stray weeds out there that escape management, from whatever you sprayed during that year, think about removing those. You don't have to remove the whole plant, just make sure the seed doesn't drop to the soil. So weed removal, or some we might call that harvest weed seed control tactics, is something that could be done. And the simple form of that is just hand pulling the weeds and removing them. The other more advanced stages might be some of these hammer mills on the back end of combines that can destroy and devitalize weed seeds during the harvest operations. Most of it through like soybean or small grains, but also through corn harvest. If you have a lot of weeds, you'll have some weed seeds moving through that combine as well. So managing the weed seeds year before is an important part. And the reason I mention that is we sometimes gloss over that. Like, yeah, everybody knows that they should manage weeds if they're out in their field, but very few actually do it. And we need to do more of that because it is putting excessive pressure on our herbicides, which is the other thing that I was going to talk about. So Herbicides, we're at a little bit of a crossroads here. We've benefited from a lot of great herbicide discovery and novel chemistry being brought to market for decades. But as it's been said by several weed scientists and several crop specialists and farmers, that we were spoiled until around 2010. And that's when we started to develop some challenges that were really painting us into a corner. And so those would be weeds that were resistant now even to Roundup. And yes, we have 2,4-D and dicamba and Liberty that we can utilize in different soybean systems. But even those aren't long-term solutions. Those are going to be short-term. And in some cases, they've already ran their course on some fields in the U.S. and soybean production. So we have to think beyond that. And what goes beyond that? Well, cover crops are a part of it. Focusing more on the soil residual herbicides are a part of that. And not just putting or betting the bank, if you will, on the post-emergence herbicides applied in season, because that's where all of our resistance has gone really over the last 20 some years. And there's no way to recover from that during a growing season. If you fail your post-emergence application, the likelihood is you come back with the same post-emergence herbicide that you just failed with. That is not a sustainable solution. So I think minimizing how many weeds are in the field by harvest weed seed control practices, using soil residual herbicides, cover crops can be part of that. However, that's another balancing act that, yes, I want cover crops. I want to be able to seed them in the fall, but I know residual herbicides could potentially have carryover concerns to those carry over in the fall for those cover crops. And so, no-till and cover crops, it's not something where you can just read a recipe and bake cookies. It is more of an art form. And I think that's an important part of weed management. I was reviewing some of our research this afternoon that is funded by the United Soybean Board. And it's done at multiple states. University of Wisconsin, Rodrigo Worrell is leading the effort, but there's, I want to say, maybe 14 different universities involved in the research. And what was interesting in that is, in our research, we showed that I think it was 4,500 pounds of cover crop biomass is what effectively reduced pigweed growth, so water hemp and Palmer amaranth. But it's at those levels that we also started to see a reduction in the stand and rate of growth of our soybeans. So how do we develop that, planting green system with high biomass and make sure that that's effective for the weeds to suppress them, but we're not suppressing our crop? And I think there are probably methods that you can do in terms of in-row management. And, whether that's some mechanical form, zone tillage, if you will, or just like a lot have using some sweeps to move away some of the residue. But I know others have been successful where they don't even use the sweeps and they plant into that thick rye or whatever that cover crop might be. And so they're doing some things that, we need to learn from so that we selectively promote better crop growth while we still have the advantage of suppressing the weed growth, because that's, the cover crop doesn't know the difference between your crop and your weeds. And so I think as a farmer, you need to help the crop gain an advantage in that situation.
Right. And for all of the no-till farmer subscribers who are out there listening, we're going to have an article about that very study that Brian's talking about with the 4,500 pounds of biomass in the January issue of No-Till Farmer, so keep your eyes out for that. But yeah, that was one thing I thought was interesting with the University of Wisconsin study, was looking at how that not only they found this ideal 4,500 biomass, but then how that affects your soybean stand. And it's like another level of management that you have to take into consideration when you're thinking about using this on top of all the considerations with your herbicides and all of that too.
Yeah. And, it's been proven over and over that it's sheer amounts of biomass where cover crops will help suppress weeds. It's just how do we manage that in a way that we still have optimal crop growth, and that's where the challenges come in. And it varies by crop, of course. Soybean seems to manage that situation, planting green, a little bit better than corn. But I know some no-tillers have been successful even in planting their corn in green situations. I think that's one of the things that's very environmentally dependent. How cool and wet was it in that geography when you were successful or when you failed potentially, or not failed, but you were challenged significantly. And I think those are the things that we need to learn about a little bit more, and how we can manage each of those situations, not just, well, you need warm, drier soils for your crop to come out quick and start growing and compete with the cover crop. Well, okay. But somewhere in the Corn Belt, we're going to have the adverse conditions. And so how do you manage that? Because you need to be successful every year, not just years when the weather cooperates. So I think there's opportunities for research there. And again, I think management tactics that you can use in the crop row, that's where we have the advantage, where we can do something there, but the row middles, we can still suppress the weeds a little bit more effectively. And I think what we've learned long-term over the cover crop research is the cover crops have supplemented our herbicide programs. They haven't eliminated a whole lot, at least in our research, but they made it more robust. And I think that's a win, because if you're trying to control fewer weeds with herbicides, there's less selection pressure for resistance. So we can't forget that. And I think that's something that, when we look at the bottom line, well, I'm suppressing some weeds with a cover crop, but I'm still spending the same on herbicide. Some growers view that as, a failure of some sort. Like, no, I needed to lose something here. But what you're gaining is resistance management and how robust that practice is. And I know it's hard to put a dollar value on that when you pay the bills every year, like a farmer needs to. But I think there's a lot to be said for the sustainability component of it.
Right. So in terms of managing resistance, first kind of set the stage for us. How quickly is resistance developing, and how prevalent is it across the Midwest?
Well, in the Midwest, right now, we assume that if you have water hemp or horseweed, mare's tail, it's resistant to glyphosate or Roundup. There is no farmer in state of Indiana or Illinois or Iowa that I could think of that, they've done certain things right. They don't have those resistant weeds. They have the susceptible forms of those weeds. I'm not familiar with that. Those two weed species have spread extensively with glyphosate resistance. So we assume that we're dealing with glyphosate-resistant burn down weed in mare's tail or horseweed, and then also dealing with a summer annual weed like water hemp that's resistant to glyphosate as well. And so that's where it starts. Now, in most cases, the water hemp is going to be resistant to multiple herbicides, the ALS inhibiting herbicides, in many cases, what we would call the PPO inhibiting herbicides like Cobra and Flexstar. Whereas mare's tail might be resistant to glyphosate plus some ALS inhibiting herbicides like First Rate and Classic, which have been, great reliable herbicides in the battle of mare's tail in no-till production as burn downs. But because of ALS resistance, we've seen a little bit of increase in where they're not as effective as they used to be. So I would assume if I'm talking to any farmer in the Midwest that they probably have those two weed species with herbicide resistance. Now, of course, there are some that will claim they don't have it. Maybe they don't. But I assume the worst because it's frequent enough. Those are the questions that we always get. When I talk to farmers about management of weeds, if they're not asking questions about water hemp, it's because they don't have it. Because if you have it, management is the challenge, of course. So in terms of how fast things change, I'd say from 2012 to present, we saw a big change in the frequency of glyphosate resistance on some of these fields, especially for water hemp. Mare's tail, we've had that since early 2000s. But really what happened since 2012 in water hemp is we added that PPO resistance to it, where Cobra and Flexstar wouldn't work anymore. That's when we were painted into a corner, and we had, we really had to start using more Liberty Link if it was available, or started to use dicamba, even when some had second thoughts about whether they wanted to use dicamba or not. And then now Enlist, or the 2,4-D system. But in some screening work that we've also done through United Soybean Board, where we've done random collections across several states on an annual basis for the last, I want to say, 5 years, in our greenhouse screen to 2,4-D and dicamba and glufosinate or Liberty, we've seen that we've had a greater frequency of weed surviving the field use rate in our greenhouse screens over time. So we've seen less effectiveness in the populations that we collect year after year. So is that reflecting resistance in the field? No, that's not confirmation of resistance, but it is a change in how well some of these populations can survive, let's just say a benchmark treatment in the greenhouse. And if they're surviving better in the greenhouse, that means that the chance of failure in the field has increased as well. And we just need to be cognizant of that, because we weren't concerned that much when Roundup stopped working, because we could just increase the rate. But in the case of dicamba, there's one rate that is labeled for use in Extend soybeans. You can't apply a reduced rate. That's not according to label. You cannot apply a higher rate. That's against the label. There is one rate. 2,4-D, we have 2 rates that we can use. Most are already at the higher rate in many cases. So we don't have much rate flexibility there either, like we did with Roundup. And then Liberty, the rate of Liberty that we apply today to manage water hemp is about twice the rate that we used in the late 90s when we first had some Liberty Link corn. So that should be a little bit alarming, because that, 50% of the rate we use today was effective back in the late 90s, and now it no longer is. So we've seen a change in response to that herbicide as well. And there's been confirmed resistance in Palmer Amaranth in Northeast Arkansas for glufosinate or Liberty herbicide. We've had confirmations of water hemp and Palmer Amaranth with resistance to 2,4-D and dicamba. Are they widespread? No. But we hear of fairly common failures with the auxin herbicides on water hemp and Palmer Amaranth. And that's concerning.
Definitely. So how likely is it that we get to the point where our current herbicides don't work at all?
Oh, I think by the end of this decade, there's a good chance there'll be some fields where the auxin herbicides and glufosinate, Liberty, don't work anymore on important species like Palmer Amaranth and water hemp. I think that's pretty easily said, because in some fields we already have, one or maybe 2 of those herbicides that have stopped working. So now we're just relying on the other one, the third one, to take us home the rest of the way. And I don't think it's going to last for 6 years. We don't have that much time. Even if we practice good crop rotation and only apply it 3 more times. But there's a lot of herbicides we apply in our corn that we're also applying in our soybeans today. And that's the other thing that we've done is, if a herbicide worked in corn, we decided, well, why don't we use that in soybeans as another tool? So that's where, we really aren't rotating away from some herbicides like we used to be able to when we had, let's just say, non-GMO crops, pre-1996. After herbicide-resistant crops, that's when we enabled a lot of herbicides to be used in corn and beans, because they're good and effective, and why not use them? Well, it contributed a little bit towards herbicide resistance evolution. Is a good reason why we should not have.
So how often should a farmer be rotating away from herbicides in an ideal world?
So, if I were to get technical, I would say, let's start with the post-emergence herbicide. So the last herbicide you apply for the year, that's the one I would focus on rotating the most from year to year, because it's the last herbicide that you apply is probably going to be the biggest selective tool in developing resistance, because those weeds in that field survive that herbicide in both years possibly. And we know that's going to drive resistance. The soil residual herbicides, if they're still working, and hopefully they are, of course, we always have a post-emergence herbicide to, hopefully control those weeds, and hopefully those that were potentially resistant to the soil residual herbicides, they don't go to seed because you use an effective post herbicide. But if you have resistance to the post herbicide, typically there's no turning back. You're not going to fix that unless hand weeding is involved, and these harvest weed seed control methods are enacted in the fall of the year. So that's where I would start. But how often should we rotate, or how much should we rotate? I'm afraid that we're in a situation where we don't have the luxury to rotate as much as we want to, because we don't have as good a herbicides in soybean. We end up using the herbicide in both corn and soybean. So let's just take the group 15 herbicides. So the Ziduas, the duals, the Cetaclor products, those help atrazine. They work very well with atrazine in corn production. They work very well with the group 27 bleaching herbicides like Balance and Callisto and that family of chemistry. So I would hate to pull those out of corn production, those group 15 herbicides, because they complement those other herbicides very well in corn. But we really don't have a lot of other options for the layered residuals that we talk about in soybean production. After you have soybean emergence, it's really the group 15 herbicides that bias some of that residual weed control. And that's problematic, but I can't in good faith say, we should stop using group 15s in soybeans today, because we just don't have an alternative. Because if a farmer says, okay, I'll stop, what else do you want me to use? I wouldn't have an option for them. And if you think about some of the no-till production system that we have in soybean right now, planting green, delayed burn downs, some of the other herbicides like the Valor and Authority type products, if you apply those prior to soybean emergence, right at soybean planting, that means you'd have to terminate your cover crop at that same time. And that's not what some no-tillers want to do. They want to, plant green and get, maybe 2-3 more weeks of growth out of their cover crop before they terminate it. So after planting soybean. And according to some of the research that we've done, it's about 3 weeks after planting. If it's very early planted soybeans, that's some of the, I think, exciting research that we're doing this year. That it's probably a no-till article that you're doing with Rodrigo as well, possibly the early planting component. But that's fine. It's a collaborative project. But 3 weeks after the very early planting, so April 1st, 3 weeks after is when we finally got to the cotyledon stage of emergence. So the cotyledons are showing, and that's when we finally achieved the right level of biomass for the cover crop where you can terminate it now. But at that point, you can't apply the group 14 herbicides like Valor Authority anymore. You'd have to go with the group 15 herbicide. So I think the group 15 herbicides are pretty compatible in planting green operations for no-till in soybean, whereas some of the other residual herbicides are less compatible. If we talk about metribuzin or Sencor, Tricor type herbicides, or the group 14 herbicides, Valor and Authority, if you applied that right at planting your soybean, that's going to be injurious to your cover crop, and you're not going to continue to get several weeks of growth to meet some biomass expectation or target.
Mm-hmm. So talking about, I believe you said it was the group 15, there was no other, there's no option for another herbicide to rotate. And that's where it seems like maybe we're seeing a lot of technology development with the mechanical weeding methods. Seems like maybe that's where that could fit in. So I'm wondering what options in terms of technology and mechanical weeding do you see as the most promising right now?
Right. And I have done quite a bit of My research program has had more emphasis in site-specific weed management, new technologies. And so let me just take two off the list pretty quick for a no-tiller. Weed electrocution. Weed electrocution can be dangerous in no-till high residue environments. You can set the field aflame because of the sparks that occur if you have dry residue, crop residue or weed residue, cover crop or cash crop residue. Because I had a colleague of mine look at it for no-till burn down in mare's tail. Hey, instead of a herbicide and burn down in the spring, why don't we try this? Just lower the electrode and in a no-till environment, control mare's tail. And he sets the crop residue on fire in the field. So that's not an option. Flame weed control is another one that we hear about sometimes that they have used. And obviously that is not going to work very well in no-till situations. So we just take those two off the list. They're getting a lot of attention in specialty crops, but might not be the best fit in high residue no-till environments. I do know some in organic production using the weed zapper, weed electrocution. But again, I would be very concerned if you have high residue environment that's dry. So just some watch outs there. Now there are some mechanical weeders, which they can, they have sensors or onboard cameras that can sense where the weed is and then kind of take a traditional cultivator shovel, or you could envision it being a mechanical hoe, if you will, and just kind of chops out the weed real quick. But in a no-till environment, you know, that type of soil disturbance might be less than ideal. It might be difficult to do if you have, you know, a very thick mat of cereal rye possibly. So another option goes towards the herbicides, like a John Deere See and Spray, not to be a commercial for them, but everybody recognizes when you say See and Spray. So that's the targeted spray applications that are driven by onboard, you know, computer vision is best way to describe it. So how can that help with management of some of these weeds? Well, a farmer might be more willing to use herbicide programs a little bit more expensive because they're not applying it to the entire field anymore. It's just certain locations, and whether that's a 30% reduction in the post-emergence herbicide, or maybe it's a 75 or maybe an 80% reduction. It depends on the situation. But I can tell you that cover crops in a no-till environment would help reduce the amount of the field area being treated with a targeted spray later on in that post application, just like using a good robust soil residual herbicide will in a traditional no-till environment. So I think the targeted sprays work well with the growers who are using good, solid residual herbicide programs at planting in the burn down system, those who might even be using the cover crop system to help suppress weeds as well in combination with herbicides. So I think that can be a tool. And so I mentioned one benefit about maybe you're more willing to use a more expensive herbicide program if you're not applying it to the whole field. I really see the one big benefit moving forward, and I hope we get to this point, is when the applications are so targeted that you are to some extent selectively applying it to the weed and you don't get much on the crop during that post application. So instead of having a herbicide that's selective, you apply to everything in the field, corn, soybean, weeds, the crops survive because they can metabolize it. Mm-hmm. Well, maybe we can use new chemistry where the crops can't metabolize it. You just have to make sure that you don't get the herbicide applied excessively on that crop. So it's very targeted spray. So instead of thinking like a shielded sprayer, think of it as a very precise targeted spray where you don't need the shield because the nozzles are doing that work for you. Will we get to that point? I think that the technology can get there, yes. The question is, are we going to see herbicides available for use in that type of situation? And are those new herbicides going to be something that can control current herbicide-resistant weed biotypes? I think the chance or the potential is there. And I see benefits that those in soil conservation, the EPA would appreciate as well, because, if you think about it, it's about reducing pesticide waste. If there isn't a weed there, why spray it if it's only a foliar active herbicide? So the EPA can even appreciate reducing pesticide waste. The general public can appreciate that message as well. So I see the technology coming. I think it's going to be slow because there's going to be there's a learning curve, and there's different players involved. It's not just the spray company, that makes the sprayer, the equipment. You have to have the herbicides labeled for that type of use, which is different than what we have for most applications today. There's a few herbicides that have directed spray in crop on their label. The intent was it was directed spray with the shield, not just by using nozzles. But it's still on some herbicides today that can be effective. And then, of course, I hate to say this part, but will a farmer jump to that opportunity out of the gate, even though they're managing weeds today very, very effectively in whatever herbicide-resistant crop trait they have, whatever herbicides they're using? We're probably going to push it at the farm gate level with, if it works today, I'm going to try it tomorrow. So unfortunately, we're not going to integrate another diverse management system with what we have been doing. We're just going to go to that other management system when we have to. And I don't know how to break that cycle. We haven't broken that cycle for 20 years now. So I actually don't have the solution. But I think it's important to do the research to make it available, that it is an option for those who want to use it.
I'd like to take a moment to thank our sponsor, Yetter Farm Equipment. Yetter is your answer for success in the face of ever-changing production agriculture challenges. Yetter offers a full lineup of planter attachments designed to perform in varying planting conditions. Yetter products maximize your inputs, save you time, and deliver return on your investment. Visit them at yetterco.com. That's YETTERCO.com. Now let's get back to the conversation.
That's interesting about technologies. Just going back to that simply, I know we've talked about that in No-Till Farmer magazine about the flame weeders and all of those things, and just simply how they're not developing them with that high residue environment in mind. And then thinking too about the different applications for something like a See and Spray, and how that can be more than just what we think about it as today, or what it is today.
Right. I guess one that I didn't mention is the lasers. Yes, we are using lasers for weed control. And again, this is being driven in specialty crops. But if you think California lettuce production, or whatever crop they might use it in, that's a tillage intensive system that they have out there. Very, I don't know if I've seen one of those lasers used in any no-till environment yet because of the fire hazard. Maybe that's work that can be done somehow, or maybe you just have to time that application right after a rain and you can go control your weeds with lasers in a safer situation. Or maybe there are some weed species that are more resistant to ignition, I guess.
Yeah.
I don't know. We do know that some weeds have different leaf surfaces. Silicon, which would be resistant a little bit to fire, is common on a weed species, scouring rush, but it's not a major weed issue. It's a nuisance weed right now. It comes in from the field edges and ditches. But we do know that, some plants vary. So maybe there are some cover crops that are less prone to ignition. And if you combine that with, some improvements in how those technologies are managed in the field, that would be less of a fire hazard. I don't know. I don't want to count technology out on that one. I want to give it, the opportunity for innovation to take effect. And maybe there is a way. We just haven't thought of it yet.
One other technology I want to touch on, because you'll also be speaking about this at the National No-Tillage Conference in January, is using drones for spraying. And that's something that we are hearing a lot more about, and we know no-tillers are getting more interested in. So Could you kind of give us an overview of the practicalities of that in a no-till environment?
Yeah, certainly. So the drone pesticide application become kind of, it's really caught on last 2 years. Something that I've, heard about for many years, but the last 2 years, there's just been a lot of interest to the point where there's a lot of companies that have started with commercial custom application services for drone applications. And those, have been largely driven by fungicide applications, especially in corn. Tar spot probably helped that out a little bit in gaining some popularity. But it's where, fields have irregular shapes. Maybe, the soil conditions don't allow wheel traffic. Maybe you're not first on the list to get a traditional aircraft in there for a fungicide application. You're low on the totem pole, as they say, because you're too small, not enough acres. They're going to go to somebody who has 2,000 acres to spray instead of somebody with 200 acres. And that's just the way they, prioritize their spray lists. They're going to get to the big fields first because they can cover a lot of areas. But, making timely applications in different shaped fields, I think that's where drone applications make sense. And I think fungicides, especially in corn, is where they have a lot of utility. We're still learning best applications, though, because I would talk to some, even in the Purdue Extension Service, that have been using some of these just to gain experience at their research stations and talk about them with some of the growers as they consider utilizing drone services. And my question is, do they work? And they said, yeah, we had pretty good disease management, and we used these herbicides, and it was real good burn down. I thought it was effective, but there's really not a lot of data collection. And so, as a scientist, that's where I tend to say, okay, let's see what they can actually do. And that's where I've gotten involved recently, is with the herbicide applications. But I think there's a lot of different types of drone platforms that are being sold, different models, manufacturers, different sizes. And then the manufacturer will say, well, we have an effective spray swath of 30 feet. Well, so you take it out there and you have the drone height at a certain position that you should get that 30-foot spray swath. And you notice, you know what? Yes, there's spray out to 30 feet, but it's not the same as the interior portion that was sprayed in terms of spray coverage. So it's not a uniform application. I think that's something that farmers, whether they're going to hire somebody to do it or they're going to buy their own drone and do it themselves, have to be thinking about uniformity of that spray swath. Because I did see a picture from a commercial field this year that was sprayed with a drone for tar spot, and they had 20 feet where you could tell had 20-foot passes, I should say, where they had, they did alter the progression of tar spot in that cornfield, but they were spraying based off of the 30-foot swath. So in other words, the edges, they didn't do very well on those edges. So the spray swath wasn't, that was marketed and mentioned, you're going to get droplets out that far, wasn't the effective spray width. So it varies. And that's going to influence herbicides as well, especially contact herbicides if you're spraying glufosinate or Liberty versus Roundup or 2,4-D. So you have to know what pesticide you're spraying, what type of coverage you need, and then, the different nozzles that are available. We're concerned about some drift and off-target movement, certainly with those nozzles, because they're really small. And then, just what happens with the rotor wash is kind of interesting to watch. So I'm going to have some video of that in my presentation at the conference, of course, and looking at how deposition and weed control might change as you move out from the center of the drone to the extreme edges of the spray swath, because that's what we need to be knowledgeable about, is how effective is the pesticide application? Not just are there droplets out there, but was it an optimal application? Because we don't need to compromise herbicides any more than we already are. We just talked about some of the herbicide resistance issues. If drones compromise herbicide effectiveness even more, it's like we're, inviting resistance to occur, even 1 or 2 years earlier than what it would anyhow. And we don't need that. because the herbicides we're talking about in drone applications are the same ones that we rely on post-emergence in our crops. Now, another use for herbicides that I've heard about is not just going to individual weed escapes in the field, that might be herbicide resistant, but late season weeds like vines and corn. So burr cucumber, morning glory, I hear about drones being used for those applications, which might be spotty, where you might have had, a little bit thinner corn stand, or you just have a little bit more of that particular viney weed that the residual herbicides gave out on, and they just came up. So there's one story this year, kind of close to where I live, that the burr cucumber was so bad in a cornfield that they're going to take a drone out to spray it. But the center pivot irrigation system stopped. It couldn't function anymore, going through all the vines because it was pulling the crop down too.
Oh my
gosh. So they couldn't operate it anymore. And they needed to essentially do a harvest aid to get rid of it. And a drone was the best solution for that, because even a ground sprayer wasn't going to have access because all the vines, if the center pivot irrigation couldn't traverse the field very well, then a ground spray rig wasn't going to do any better. So that's where a drone made a lot of sense. So, I think drones have the opportunity to improve pest management. I just want to make sure that we don't, open the door of opportunity for reduced herbicide or pesticide effectiveness and invite resistance issues, or, reduced return on investment.
Mm-hmm. So in terms of the having limited effectiveness across that 30 width swath, what's the solution to managing for that?
Well, I think in some cases, depends on the design of the sprayer that you have and the size of the sprayer, because, the bigger drones, bigger payload capacity, the more rotors you have, or the more powerful rotors, you might be able to get more of a wider spray swath. But if the manufacturer says, well, from an engineering standpoint, on a 2D surface, just spray calibration, we're getting spray droplets, uniform out to 30 feet. But is that moving into the canopy? Because, in some of the video that I'm going to show, it comes down underneath the drone and then washes out. And I don't think moving across a canopy is the same as moving into the canopy to control a disease or a weed. And I think we need to understand that in some cases, you might need to use a 20-foot spray swath. It's not a 30. It's going to take you longer to spray fields, but if you want to make sure you're using the pesticide well, accept the fact that it's a 20-foot spray swath or a 25, and it's not a 30. It's going to take you longer to spray that field, but it's what you need to do to avoid any inconsistency in activity of the pesticide you're using.
Right. Well, I'm looking forward to your drone presentation and the general session one, and I know we're about at our time here, so just wanted to ask if there's anything else you wanted to add or mention before we go.
One of the problems is, for somebody buying their own, it takes one person to drive a rogator across the field. It takes two people to spray with a drone, according to FAA regulations.
Oh, really?
Yeah, you have a pilot and you have a visual observer. So they don't want the pilot dealing with the pesticides. So the visual observer is supposed to be your mixer and loader. They do not want the pilot doing that. And that's something that is not done by some of these companies that provide the service. So I don't know at what point, or if we will ever see FAA get involved in regulating. Well, they are regulating, but enforcing some of their laws that they have, regulations, because that's something that you don't normally hear about when you see pictures of people, piloting a drone. You don't see somebody else out there who's the visual observer, but that is a requirement for making pesticide applications.
Wow.
So it takes two to make a spray drone application. And if you're a farmer, you might not have the extra person just, hey, stand here. Now, that person doesn't have to have any special training. So you could have, maybe you could have your kids out there or spouse or whoever. But, do you want them out there while you're making a pesticide application too?
Right. Yeah.
So it would be good if they had some knowledge, pesticide safety, pesticide applications. So it's just something that, it's not a one-for-one trade-off, ground application versus the drone, because there's people involved. And in terms of insurance, that's the other big one. If you're currently insured as a farmer to apply your own pesticides with your ground application rig, probably there's a 95% chance or greater that your insurance company does not insure an aerial application.
Mm.
There are only certain companies that will insure aerial applications. So it's the same companies that insure, the air tractors of the world and those traditional custom air applications. Those are the companies that it would insure a drone. But most farmers don't have those companies as their insurance provider. So that's the other thing. I don't know how many are fully insured if they're making their own drone applications.
Right. Yeah.
And, what are the odds that something will go wrong? I don't know, but you don't want to find out.
Right. Exactly.
Because that could get into FAA will be consulted as well. Well, here's what happened. Was this okay? No, that wasn't okay. So I don't know. I think right now adoption's been so rapid that enforcement of different policies and laws have been kind of lax. But will that change? I haven't heard of the FAA being easy on anything.
Yeah, right.
Yeah.
And
so,
that, from my understanding, there's a lot of state regulation with it too. So it's like there's this whole, it's like patchwork of regulations. So like if you're going to do it, you really have to do your research, it sounds like.
Yeah, I'm trying to remember, there are some states that don't allow drone aerial applications because the US EPA have left it up to individual states to enforce. So the US EPA has not, they feel they don't have enough information to determine if drone applications should be regulated differently than traditional aerial applications of pesticides. So my understanding is in Canada, they are considered different. So you need a specific pesticide label to say it's approved for a drone application before you can do that. It doesn't fall under the aerial application section of the label. In the US, the US EPA left it up to each state. State of Indiana, you can make those applications with the drone using the aerial requirements. But if you actually read through the aerial requirements, some of those are not what you want to do for a drone.
Oh, like what?
Yeah. How high the sprayer is, the fixed wing aircraft, the airplane versus a drone. The spray height might be different because of how the swath is applied. Some will say that, well, your travel speed is another one, because travel speed is how they manage some spray deposition with fixed wing aircraft. We're not going to do 80 mile an hour with a drone.
Right.
And so that terminology has nothing to do with the drone application. So travel speed, spray swath, the types of nozzles used, or spray height, I should have said, all those are potentially different. How the adjuvant chemistry interacts with that, we really don't know quite yet. There's different types of nozzles. We have some that are the spinner nozzles, which we used back in the 1980s when glyphosate was being used in no-till burn down situations. But we moved away from those because they're hydraulically driven and every nozzle body was a hydraulic motor. Now they're just electric motors. But we have some spinner nozzles and then we have some traditional nozzles. So there's a lot of new factors that drones introduce that aren't addressed on herbicide labels. So I was at a workshop And the consensus, our goal was to read through 2 pesticide labels through the aerial application instructions and determine what was different or what should be different for a drone application. And I think it was 2 hours we spent on it. And I think we only got halfway through one of the labels.
Oh my gosh.
And so I recommended that if it's going to be applied with a drone, it needs to be a supplemental label, because the current labels don't have enough guidance on drone applications for any pesticide right now. So we'll see where that goes.
Yeah.
But it's still being debated. But there are organizations like Crop Life America that are involved in some of these working groups that they have. So, like I said, the interest has been very rapid last 2 years. What we should actually do and how it needs to be regulated has not caught up at all. So, some people are being very effective at what they're doing, but they've had a lot of freedom too.
Yeah.
So we're just trying to learn what is best. So that's why some research is occurring, because we don't know what the best situation is in terms of making these applications.
Yeah, well, I'm glad that at least somebody's working on it, so we can kind of get some kind of standardization or best practices at least.
Yeah, and that's what this publication is going to do too, is highlight some things you don't want to do, as well as some things you should do. So it's not going to be the last chapters, here's how you optimize your herbicide application. We're not to that point, unfortunately. Mm-hmm. Too many variables. Like all the fixed wing aircraft, there are known standard designs and nozzles that they use. There's no such standard for drones right now.
Oh.
Right. So the EPA likes the standardization that has occurred for aerial applications because they can manage drift based off of that. With no standardization with the drones, they don't know what type of drift we're talking about and how one parameter might influence it versus another.
Mm-hmm.
So we're moving in that direction. We're just in the early stages.
Yeah. Who would standardize it? Like, who would make that rule?
Well, there are some from the spray side of it. So the ASTM standards, American Society of Testing Materials, so engineering based. It could be done by the EPA as well in terms of label requirements to reduce drift. There is the Spray Drift Task Force that was heavily involved with, traditional aircraft applications. They're addressing it to some extent. So there is a task force addressing some of these. But I think some of it, the drone manufacturers and how they design them. Some say that, we're moving completely over these spinner nozzles. Controlled droplet applicators is what we historically called them. Others said they're going to use a conventional nozzle system like a, spraying systems T-Jet, because they like that simplicity. So I think at some point the drone manufacturers need to get on board, but I think that'll be driven by regulations.
Yeah, for sure.
And I think there's going to be some guidance from the pesticide manufacturers too.
Okay.
They're going to develop their research database and say, you know what, this is what we feel optimizes our herbicides activity or our fungicides activity. But right now there's too many configurations of drone sprayers to, enforce that, because it might only reflect 10% of the spray drones out there. You just eliminated your pesticide from being used with 90% of the drones. And
right.
Nobody wants to make that jump yet.
Well, a lot to learn for sure. I'm looking forward to the conference, and
I'm looking forward to the conference as well, of course, because both presentations I'm going to be talking about how to integrate different tools to improve weed management. And it's not just, what herbicide resistant crop do I have this year, or what should I go with? It's not going to be about what novel new herbicide do I have that I can apply next year or in 2 years or 3 years or in 4 years, really. we just don't have that pipeline coming. So we have to integrate other methods or other technologies to make what we currently have last longer. And that's really what both talks are about, trying to preserve our weed management tools today by bringing in new opportunities for weed management.
For sure. Well, thank you for joining us today. And anyone who has not registered for the conference yet, head to no-tillconference.com and get yourself signed up. And hopefully we will see you in Indianapolis in January.
Thanks to Brian Young for today's conversation. A video and transcript for this episode are available at no-tillfarmer.com/podcasts. And if you haven't already registered for the 2024 National No-Tillage Conference in January, go to no-tillconference.com and use code PODCAST when checking out to save $50. Many thanks to Yetter Farm Equipment for helping to make this No-Till podcast series possible. From all of us here at No-Till Farmer, I'm Michaela Faulkner. Thanks for listening.